Hi everyone, and welcome to our video on using exponential functions with a interest problem. So whenever you have interest being compounded continuously, we again know it looks something like our a equals pe to the rt or a equals pe to the kt. So we saw a problem like this, so there's these other ways that we see it. Okay, so it doesn't really matter the form as long as we know as soon as we have compounded continuously, we've got something that looks like this equation. All right, so I wanted to underline that first, but let's read it carefully. It says a family wants to set up a college fund that will be worth $50,000 in 18 years. Okay, so that's an amount after time has passed. Amount after t equals 18. If interest is compounded continuously at 2.6%, okay, so they often use K in these problems. I'm going to use R though, and I'm just going to use this style formula and point out what those are. Okay, so the 2.6% is an interest rate, but we would need to change it to decimal form, which becomes 0.026. So you just move this big decimal that I'm bolding left 2 and then get rid of the percent symbol. And then it says, what should the initial investment be? Initial, so the initial is P in this problem. Okay, so the amount after T equals 18, that's going to be the A value, that's the 50,000. And then what we're trying to find, we're going to try to find the P in that equation after T equals 18. So we have almost everything set up ready for us, but we'll just plug it into that equation now. So I wrote it down over there, but let's get a little closer one more time, and then let's do the substitution. So they're saying $50,000 is equal to what we're trying to find, e to the 0.026, and then they did say 18, so times 18. Okay, and so what we can do, so we want to solve for this p, but let's simplify what we've got in that power. So we've got 50,000 is equal to PE, and then let's type that in, 0.026 times 18 is 0.468. Okay, so that's what that simplified into. And so what we need to do is divide, and we will use our calculator again after this, but what we need to do is divide whatever this number is on over. That will give us the p-value by itself. Okay, so I just need to type that on the left into the calculator. So we've got 50,000 divided by e to the 0.428. Let me double check. 468. There we go. Okay, so we get this, and we'll round this to the nearest cent. So it looks like it should be $31,312.68. So $31,312.68. Okay, so that's it though. That is the initial investment. Okay, so if we want in 18 years to have $50,000 using this account, we need to put in about $31,000 and let it grow. Okay, so it takes some time. Okay, but that's that. Okay, so this is again just a different scenario. So the main thing out of all these videos and these sections that we're watching currently, so exponential growth or decay, is to set up these equations with our whatever p equals or a equals pe to the rt or n equals ne to the kt, whatever. Okay, and sometimes they might start it off like this, where we can still convert it, but the main thing, if you see exponential growth or exponential decay, we're converting it into an exponential equation. And this is just a special case. Compounded continuously is always an exponential equation as well. Okay, so that's that. If you do have any questions, please let me know. Otherwise, thanks for watching.